Rather everyone. So I think I'm audible, right? I like from my end, I guess I'm properly audible. My latency of the video, it was having some issues earlier, but now I think it is fixed. Okay. Uh, okay. So in case if you guys feel that there is some lag from my end, I think it is running okay, no? No. I think it's running okay. Still, I'll just check it by myself. Okay. Arey, you know what happened? It happened like I ran into a BDS. Okay, I ran into a blue death screen, blue screen of death. BST, right? I don't know what it's called. Anyways, whatever it's called, I ran into it. I just need someone to confirm me whether I'm audible or not, I'm visible or not. Okay, then only I can start with the live stream. Yeah. Okay. Properly, right? Okay. So like properly as well as damn good. I sound damn good. Okay. So let's first of all, okay. So a brief summary. Like I will be explaining subset sum tree, yet another monster problem, and k boxes and swaps in good to go. Yeah. Swaps in a string and inversion queries. Okay. So these are the problems that I'm going to discuss today. So before discussing the problems 1, 2, 3, 4, the last problem inversion query. Sorry, I'm not going to explain the inversion query. So last problem, it is I couldn't code it because like I don't know, my system was having some issues. I generated it from AI, but I haven't submitted because obviously I will get some flag if I submit. But I think it works. Okay. So anyways, I won't discuss it because I'm not sure about the solution. So yeah, that's it. Let's start. Huh? Okay. The first problem, subset sum 3. You're given an array A of n integers, determine if there exists a non-empty subsequence of A such that sum is divisible by A. Divisible by 3. Print yes or no accordingly. You do not need to print an example of such subset. B is said to be a subset of A if B can be performed by deleting some elements in A without rearranging the order of the remaining elements. It's basically like you can choose any number of elements from A and you have to make the sum of it divisible by 3. So you have to tell me whether you have to tell whether it is possible to do it or not. Okay. So let's first of all, like it's better to take some examples out. Okay. So let's take some good examples. Okay, 1515. This is a good example. See, 1515, the 5 will get printed actually. So it means that like if you take this 1 and 5, you'll get 6, which is divisible by 3, right? So it works for this. Now, the main thing is like how can you find it out? Because obviously you can't check for all of them using some algorithm like bit manipulation or maybe big O n squared. Like it is not preferable, right? It was given that you can go for n. It was given that yeah, it was given that it is 100. Oh, I get it, but it's like it's not preferable, right? It's never preferable that you do that. And it can also be proven that if you can take any three elements and check if it is divisible by, if the sum of it is divisible by 3, then like it should be divisible by 3, and if none of the three elements have its sum divisible by 3, then it is not possible. Okay, so that is also a simple thing, you can go for it. Okay, but the main important thing is like how to optimize it. रिकर्जन मार दिया हाँ वो भी होता है कोई प्रॉब्लम नहीं है वैसे this is also good but why would you do that, right? Why would you do that? So this 6, right? So how to handle this? See, if you notice one thing very carefully, if I want to make something divisible by 3, And if I want to find that how many elements that I need to add on so that it is divisible by 3, right? How can I do it? First of all, let's say if I'm going for the basic thing, 1, 1, 1, it is divisible by 3, right? Good. 1 and 2, divisible by 3. Good. And then 3. So this is the basic thing that I have to make the sum as 3 using at most 3 variables, right? It is the base. It is the base of everything. Now, if I tell you that you can convert every number into a 1, 2, or 3, won't that be like a damn good thing? Obviously, not 3. You can convert it to 0. Okay, you can convert it to 0, 1, 2. How can you do it? You can have the modulus 3 of it. So let's say if you are having 1, 5, 1, 5. So what if I make the modulus of all of them? It becomes 1, 2, 1, 2. Right? Now that I've got the modulo, what is my first main goal? I have to first of all find whether is there any one number that is divisible by 3 or not. So if it is divisible by 3, its modulo will be 0. Right? So first of all, first step, find if any one of it is 0 or not. No. Good. Next is this 1, 1, 1. Check if there are 3 ones or not. Nope, only 2 ones. Not possible. You can also go for 3 twos, right? Because it gives you 6. But there are also not 3 twos, so not a possible case. You are left with only one condition. That is, you have at least 1, 1 and 1, 2. Right? This satisfies, so it's a yes. Is it clear? Is this problem clear? I mean, is this solution clear for this problem? And any doubt like why is it happening and anything like you want some proof or somewhat like that, anything like that? नाइस अप्रोच यही होता है ये सबसे ऑप्टिमाइज्ड अप्रोच है ठीक है चलो दैट मींस दैट कोई डाउट है नहीं चलो लेट्स गो टू द नेक्स्ट प्रॉब्लम अच्छा हाँ कोड देखना है तुमको तो दिखा देता हूँ बहुत सिंपल है so what I'm doing is I'm taking the input I'm having a frequency vector I'm storing frequency of every modulo in it and checking if frequency of 0 is there if frequency of 1 is greater than equal to 3 frequency of 2 greater than equal to 3 or frequency of 1 greater than 0 and frequency of 2 greater than 0 you can't see it because of this comment okay so in that case I'll just print that it's a yes okay otherwise it's a no simple yet another monster problem there are n monsters with ith monster having a of I hit points a monster is said to be alive when he has a positive number of hit points your job is to kill all the monster to do this you can either do any of the following okay you can kill all the monsters sorry you can kill a monster completely in 1 second that is choose some monster X who is alive and then reduce its hit point to 0 okay you can completely kill one of the monsters or you can damage all alive monster by 1 hit point okay this also takes 1 second so some monsters may die as a result of the hit points becoming 0 but some monster will be alive in the second case right in this case you have to find the minimum time to kill all the monsters completely what do I mean by that so देखो ऐसा है ना कि like it's always better to take an example 151 चलो इसको देखते हैं ठीक है actually तुम्हारे पास 151 है now what you can do is first of all you can reduce the health of everyone by 1 it becomes 0 4 and 0 so it took me 1 second right after that so this guy has died this monster has died and this monster has died but this monster is alive right now you know that you can kill one monster directly also in 1 second so what we'll do is you'll make this die and it will take you 2 seconds right so this is a very simple thing now how to do this what should be the best approach to do it right very simple it is As simple as that. Whatever is over here, sort it out. Okay. So what happens now? It is 1 comma 1 comma 5, right? All of them are monsters right now. Now what you can do is, first of all, you have to divide your operation. You have to divide it into two parts. One part is kill a monster. Okay, so there are two parts. First of all, let me tell you, there are two parts. The first part is, some operations will be like, you will reduce health. Okay, or rather make it -1. Reduce health of everyone by -1. One step. And the second step is kill one monster. That is, so what we are going to do is, we are going to reduce the health for some times, let's say for k times, and the remaining number of monsters that are remaining, that are alive right now, I have to kill them directly. Right? This is the proper logic. This can be possible. But how can you do it? Like, how can you know what should be your answer, right? How many monsters you have to kill directly, how many monsters you have to reduce their health? You never know, right? But if you sort it out, if you sort the whole thing, now it becomes very easy. See, over here it is 1, right? Which means I can reduce the health of all the monsters by 1. And doing that, what happens? This, any monster that is over here or before this gets killed. Okay, in how many steps? In this number of steps. It gets killed. Right? And the remaining monsters are 2 monsters. So you can kill it using 2 more steps. So what is the answer? 1 plus 2, it is 3, right? So that is one of the approach. I mean, that is one of the iteration. Now I'll go to the next position. That is, I can kill all the monsters over here using 1 step, 1 second. And how many are remaining? There are only 1 remaining. So 1 plus 1 is 2. Right? So it is 2. Earlier was 3, it is 2. So 2 is better now. Now I am iterating to the last position. So I am going to consider this. So to have all of the health reduced to 0, how many operations do I need to perform? 5. Right? And is there anything apart from this? No, nothing. So it is 5. So we got 3 values. The first one was 3, the second one was 2, the third one was 5, which is minimum 2. Right? Let's come up with some other example so that it becomes better for you to understand. A very similar example, 1125. Okay. What should I be doing? Let's say when I'm pointing to this 2, right? So I can reduce the health of, I can kill all these 3 people in how many steps? In 2 steps, right? So I've killed them in 2 steps. And how many are remaining after this? 1. So how many do I total need? It is 3. And it is always the best approach to do this. Because if you sort it out, what you can do is, like if I'm killing this person by reducing its health one by one, but by 1 every time, then I'm already killing all the people who are before it because they're having a lower health, right? Let's say if I'm having a greater health and all the people who are having a lower health. So if I'm using the second approach, the second whatever was it, like the second what to say, the second type of action, okay, that is damage all live monsters by 1 hit point. So let's say if I am having a higher hit point and you have killed me by reducing all of the monsters hit point by 1. So if I am killed, it means that everyone who had a health less than me or lesser than equal to me has also been killed, right? Only the people who are having a health greater than me are not killed, and they can be killed using 1 step for each, right? So is this whole logic clear? Is this whole logic clear for you guys? Is it a yes or no? Yes. Okay. 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 Works. Great. So now that this whole logic is clear for you, so let's go into the code directly, right? So that you get a better understanding of what I'm doing. See, it is like I'm taking the input, okay, input, and I'm sorting it out. And you know what, like the minimum number of uh, what to say, the minimum number of operations that you need to do is basically not even n. I just made it n for my better understanding. It will be minimum of n comma AR of n minus 1, because you can either reduce the health by 1 for all of them, that is for the the last person, the last monster who is having the highest health. If you can reduce his health 1 by 1 by making it minus 1 minus 1 minus 1 minus 1 till 0, it means that you have killed all the monsters. That is also one of it. Or you can kill all the monsters individually, that is n number of them. Okay, so this is one of it. And then what you are going to do is, for all the elements you're going to make, you have to consider whichever is minimum. I mean, we have to consider like AR of I, that is this AR of I plus the number of elements left, right? Plus the number of elements left, that is n minus 1 minus I. Is the solution clear? Can I move on to the next problem, or should I explain it again? Okay, I can move on to the next problem, right? Great. Let's move on to the next problem. Okay, the next problem is key boxes. There are n thieves numbered 1 to n. The thief numbered I has a level A of I and has B of I gold. All the levels A of I are distinct integers in the range 1 to n. A thief I can steal from another thief J if and only if his level is greater than the level of the other thief. That is, A of I is greater than J. So only if its level is, okay. So shit, man. Okay. Shit. Okay. So what happened is like, uh, I'm using a stand, okay, to stream basically, but this stand has got stuck with my chair's wheels. Okay, now it is okay. See, it is like a single thief can try to steal. Okay, so it is like a thief can steal from another thief only if it has if it has a level of, it is of a higher level. Okay, and what is the level? It is defined by A of I. And what is the gold coins that a thief has? Defined by, it is B of I. Okay. And what a thief can do is he can steal at most K other thieves, not more than that. Otherwise, he will be caught for sure. Okay. So for each thief, you have to find out the maximum number of gold coins that they can steal. So let's first of all, okay. For this, I'm going to take first of all a basic test case. Okay. It is 231 and 10, 50, 20. What does it mean? It means that, let's say for the first thief, that is, he's at a level of 2, right? So from whom can he steal? He can steal from 1, right? So how many gold coins will he have? And yeah, one more thing. It was given that, I guess, yeah, it is 1. Okay, K is 1. Remember, K is 1. So let me write it over here. K is equal to 1. So whenever he's going to come over here, so he can steal from this thief. That is, he's going to have a number of gold coins as 20. Okay. So how many gold coins will he have? Sorry, will have a gold coin number of 20. For 3, he can steal from either 2 or 1. But he can't steal from both of them because K is equal to 1. So he can steal from only one person. So from whom will he steal? Using a very greedy approach, he will obviously steal from 1, right? Because from 10 and 20, 20 is greater. So 3 will also have 20. And this 1, this is the poorest guy, okay? Because he is at the lowest level. So he can't steal from anyone only. So he will have 0 gold coins, right? So if you look at the solution, it is 20, 20, 0. Now how to do it? So what you have to basically think about is, why not what if we sort this whole thing, right? Instead of keeping it as 2, 3, 1, can't we make it 1, 2, 3? And later on, we'll just find out like for 2, I will find out whatever it is. For 3, I will find out whatever it is. For 1, I will find out whatever it is. Okay. Later on. But first of all, let's sort it out. So for 1, it is 20. For 2, it is 10. And for 3, it is 50. Right? Now, the thing is, you have to understand one thing. Now that I have sorted it, it means that whenever one thief, okay, let's say this thief, if he wants to steal, he can steal from all the person who is coming before him, right? But only K top people he can steal from, right? So first of all, let's say when I'm coming till 1, obviously he can't steal from anyone, so he will have a value of 0, right? Now for 2, he can steal from anyone before him, that is 20. 3, he can steal from anyone before him, that is 20 also, right? So can any one of you think of what is a data structure that we will be inculcating in this solution? I can give you a hint. We have done the sorting in big O n log n, and we are traversing in big O n, which means you need a data structure which can inculcate a complexity in every insertion and deletion. Map, no, nahi. Log n hai, log n hai. Log n, it is log n. It's not maximum log n, it is log n only. Hint. Another hint. कुछ भी गेस कर दो, कुछ भी, कोई सा भी डेटा स्ट्रक्चर गेस कर दो, गलत होगा तो मैं बोल दूंगा, ऐसा कुछ है, कोई सा भी कर दो भाई. Well, it is a heap, okay, and heap is not heap, okay, it is not heap in normal coding terms. In coding terms, we call it priority queue rather, right? Max heap, mean heap, priority queue, comparative is priority queue. So it is basically a priority queue that you have to use. Okay. Now that you know that it's a priority queue, so what you can do is नहीं set नहीं है priority queue है. तो now that you know it, so see, समझ लो इसको अच्छे से, ठीक है. अब पूरा हम करते हैं वापस से, ठीक है. So there is a priority queue, okay. Now in this priority queue, you can insert a lot of elements. So first of all, ये तो 0 है, but the moment it is 0, I insert an element 20 in it, okay. I insert the 20 element in it. Now it is 10, right? It is 2. And you know what? It is also told that you can't steal from more than k elements, right? So what you can do is, the moment you put something into the priority queue, you can have a sum. You can have a variable called sum, and you can update it. So what is sum going to do is, sum is going to keep the track of sum of all the elements in the priority queue. So if you add something to the priority queue, add that element to the sum. If you remove something from the priority queue, subtract that element from the sum. Okay. So initially it is 20, right? Now there is a 10, right? There is a 10 over here. Now for this 2, okay, so for this 2 also is a 20, which is well and good enough. But now we have a 10, right? So we have a 10 over here. But the moment I put it at 10 over here, now the size of the PQ has increased. It is more than K, that is 1, right? Since it is more than K, now we have to think of something. So we have to pop out something. So what we have to pop out? We have to pop out the minimum element. Okay, no problem. You uh, check the what to say recorded version of the live stream. Okay, it works. Specifically, if you're having a dinner, like yeah, you can go. So let's say for this 20 and 10, now I have to remove something, right? So first of all, this sum becomes 30. Now I have to remove this the minimum. So what is the minimum? The minimum is okay, भैया चलो. The minimum is 10. Now this becomes 20 again, right? So ये क्या होगा? 20. So it is 0, 20, 20. But it was 3, 2, 1, right? Or like yeah, 2, 3, 1, which means 2, 20, 3, 20, 1, 0. So 20, 20, 0 is our answer, right? Matching. Let's do for this test case. The next test case. Okay, let's do for this test case. 1, 2. The size of the priority queue should be k, right? And the value of k was 3. Okay, value of k is 3. So 1, 2, 3, 4, 5, 29, 42, there is 2. 3 is 55, 4 is 45, and 5 is 37. Okay, so priority queue. Okay, first of all, so over here I'm going to give the answer. Okay, so sum, for now I'm making the sum as s. Okay, sum is 0 and priority queue is initially empty, right? So first of all it is 0 and then I add 29 to it. Sum becomes 29. This is sum, that is 29. Now I add 42 to it. Now this becomes 29 plus 42. What is it? It is like 9, 10, 11, 4, 5, 6, 7, 71, right? So this becomes 71. Now it is a 55. So I add 55. And this is 71 plus 55. It is 6, 7, 8, 9, 10, 11, 12, 126, right? It's 126. Now it's a 45, right? Hello. So it's a 45. So I will add 45 to it, which makes it 1, 1, 4, 5, 6, 7, 171. But over here you can see that the size of it has increased more than 3. So you have to remove the minimum element. Remove it. So minus 29. 171 minus 29. So basically 171 minus 30 is 457, 141. So it will be 142. Okay. So the value of this is 142. After that you can also make some, you can also add 37 to it, but it is of no use, okay? Because you have got all the answers. Now you have to rearrange it. It is 4 to 531. Okay. 4, 126, 2, 29, 5, 142, 3, 71, and 1 is 0. 126, 29, 142, 71, 0. 126, 29, 142, 71, 0. Isn't this so cool? Okay, so let's move on to the question, the code. Okay, so what I'm doing is, I think I'll need more space over here. Yeah, now it is okay. So what I'm doing is I'm taking a 2D vector. It is of n into 4. Why 4? I'll tell you. The first position what I'm taking is in the 0. I'm taking its position itself. In the second position, I'm taking its power. I mean, yeah, the level or whatever it is. I don't remember. Is it just the level, right? A of I. Yeah, the level. Over here, I'm taking the amount of gold he has. and the 3, AR of I of 3, it is going to give me the answer. Okay, so first of all, what I am doing, I am sorting it on the basis of this, right? And later on, to get the answer, I can sort it on the basis of this, so that I will get the original array. So first of all, I am modifying it, then I am remodifying it, demodifying it. Okay. So first of all, I am sorting it on the basis of the first index. Okay. Got it. I'm taking a priority queue which is having a greater, which means it will be returning the minimum element. Then I am having a sum for all the elements. A of I of 3 is equal to sum, and sum plus is equal to this, and I'm pushing it to the priority queue. If the size of the priority queue is greater than equal to k, obviously you know that the size is basically I only, right? So if it is k, that is the moment it starts exceeding, you can make it sum minus is equal to pq dot top. That is whatever is at the top, I have to remove it now. Okay, so I remove it from the sum, and I then remove it from the priority queue. Okay, and at the end I sort it again on the basis of the first row. That is, I am making the array come back to its original format, and then I am just putting the answer as a of I of 3. Any doubt regarding this? Yes or no? Otherwise, I will move on to the next problem. So if you want me to move on to the next problem, just write swap. Okay, just write swap. Yes. Okay. 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 And this is the last problem that I'm going to explain. Okay. Swap. Okay. Great. 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 Insane thing, pal. Swaps in a string. You're given a string S that contains of the characters A, B, and C only. Today contest dominated by a lot of cheaters. I don't know. Is it? The last problem I know it could be solved by AI itself. Okay, that's the reason I didn't like submit it. Okay, so swaps in a string. You're given a string S that contains of the characters A, B, C only. In one operation, you can do either of the following. You can choose an occurrence of A, B in the string and convert it to BA. You can choose an occurrence of BC in the string and convert it to C. Just a minute. Okay, so yeah, in one operation, you can do either of the following. You can choose an occurrence of AB in the string and convert it to B of A, BA, and you can choose an occurrence of BC in the string and convert it to C. Note that you are only allowed to operate on adjacent elements. Find the maximum number of operations you can do. You can prove that the answer is finite. Why is it finite? I will also tell that. Okay. First of all, let's take an example. B A A B. No, let's take this example. A B C. A very good example. Okay. A B C C. What you can do is you can swap these two elements. Okay. It becomes B A C C. But you can't swap anything other than this because there is no AB and no BC in this. right? So it is not like it is okay. You can do maximum one operation. But if you swap this, it becomes A, C, B, C. Again, you can swap this. It becomes A, C, C, B. You can't do anything more than this. Okay, done. So you did in this you did two operations. So how can you know what is the maximum number of operations that you can do? Right. Obviously you can't use brute force in it, right? So just think about it like this. Okay. A B C all A B C. Okay. What do I mean by that? A B C. Look at this. Okay. You can separate every if you have a knowledge about regular expressions, then this will be good for you. Okay. This is it. Okay. See, if you have no B in it, so it's a direct zero because for every pattern A, B and B, C, the B is necessary. So you need a B in it. So B is necessary. But A and C is not necessary. You can have any one of them. You can either have AB or you can have BC, right? So there is a pattern, this ABC. Okay, if you notice clearly, there is a pattern. Now let's understand this. Let's say if you're having triple A, B, and double C. What you can do is you can swap this BC. Now this becomes B. Then again you can swap this BC. Now this becomes B. Now this becomes C and this becomes C. No other swaps possible, right? Or you can do the opposite. BA, then BA, then BA. So basically it is nothing but whichever is maximum, the number of A's and number of C's, right? In this pattern. Whichever is maximum. It is what you have to consider. Take into consideration. Rather. Okay. What if there are more than one B? More than one B. There is a C over here. So for this B, it will go till over here, and this B, it will also go till over here. That is three jumps. Both of them will be having three jumps. So it is basically you have to find the pattern A star B plus C star. This pattern. A like n number. Let's say X number of A's, Y number of B's, and Z number of C's. That is it. Nothing more than that. Okay. Once you get that, once you get that into your like, once you get what is happening from that, you can find a formula out of it. That is whichever is minimum. And remember one thing: a B is always necessary. So what you have to do is, so let me just show you. Like let's say there's a A over here. Also. There's a A B C. Now this A B C it will be untouched by this pattern. This pattern can never interrupt with this ABC because whatever is over here, okay, whatever comes over here, there is nothing before A in any of the patterns, right? Nothing before A. There is something before C in the pattern, but there is nothing before A. There is something before B in the pattern, there is something before C in the pattern. Nothing before A in the pattern, right? And remember one thing, if even if it is a B, okay, if you're thinking that okay, it's a B in the pattern, not gonna affect much. Because what will happen is the element before it will be either C and CB is not a good pattern, or the element will be B and BB is also not a good pattern, right? None of them is a good pattern. But it is not B. I can guarantee you one thing: it will never be B. Okay, it will be either a A or a C because B is always necessary. So are you getting it? It is like for every pattern you have to find out how many consecutive A's are before that and how many consecutive C's are after that, and whichever is maximum, You have to consider for every specific B. So for every specific B, you have to find out how many swaps you can do. But the doubt arises when ABC is followed by BC again. No, not a doubt. Let's say if it is ABC and then there's a BC, right? This is what you mean, right? Why should this freak it out? See, see this thing very clearly, okay? When I'm telling you there are some consecutive C's, you're not going to consider the B. Okay, the B is not going to be considered only. Okay, for this B, there will be two consecutive C's. But for this B, there is only one consecutive C. No doubt, right? Now it's not a doubt, right? I hope this is what you meant. Now it's not a doubt. I'll tell you what is happening. Okay, I'll tell you directly into the code. See, I'm having a DPA and a DPC. Okay, what I'm doing is for the DPA, so obviously dp of I is equal to dp of I minus 1 undoubtedly. And if it is a A, then it's a plus plus. And it becomes 0 only if there is a C. If there is a B, it doesn't change. Okay, a B never changes anything. A C only reduces it to 0. Then only I'm going to consider that no, it is not consecutive. Right? There are X A's and then A B's and Y C's. Thereafter I can swap the B's with X A's, or else I can swap B with next Y C's. Then the number of B's are filed also. Yeah, exactly. The B is not something that we'll consider, right? It is all a thing of C, A and C. I'll tell you what is happening. I get it. I get what you're trying to convey. Okay. S of I is equal to A. See, I'm incrementing it only if it is a A. But I am making it 0 not when there is a B, but only if it is a C. Right? To be literally, a B will also be hampering the pattern, right? Of consecutive A's or consecutive C's. I'm doing the opposite thing over here. Okay, whatever I'm doing over here, I'm doing the opposite thing over here. See, I'll tell you what is happening. Okay, so for this A, B, C. So let's take an example A, B, C, B, C, right? So you're telling me that for this B, it will be 1, and for this B, it will be 0. So it will be one swap, but it is wrong because it is wrong because this is happening. You can have this B over here, ACB, and then you can have this B over here also, right? And then you can have this also over here. So there is total 3 steps, but you're getting only one of them, right? This is what you mean. But this is not the case. Okay, I'll tell you why. This is not the case because till over here, A is 1. But if you notice that C, it is 1 over here, then it is also 1 over here. It doesn't become 0. Okay, because it is B. B is not going to change anything. If it would have been A, then it would have become 0. Okay, it becomes 1 over here, then it becomes 2 over here. Right? Sorry. Right? Now what happens is, this B is going to consider 2 and 1, it is going to consider 2. So now is it clear what is happening? Sorry. Uh, I never meant the minimum, okay, I meant the maximum. Yeah, obviously you have to take the maximum between 1 and 2. Yeah. Is it clear? So for this B it is 2, and for this B what is it? It is, over here it is 0. Okay, A is 0, but C is 1. So it is 1. So 2 plus 1 is 3. Is it clear? L is equal to dpa I minus 1, that is the position just left to it, and C is dpc is the position just right to it. Clear? Yes, that's why when you find the ABC pattern, checking frequency of A and C isn't enough, because when you swap BC, yeah, right. Exactly, right. That is what I'm doing, right? So now this B will have two C's towards his right, so that is 2, and this B will have one C towards his right, that is 1. 2 plus 1 is 3. So even if frequency of A is greater than C before swapping with A might not be ideal without knowing the future sequence. You don't need to know the future sequence, no? Because you know one thing, that A can hamper the position, okay? If there is a A over here, then only it can hamper. Because anything that comes, A is walking as a partition to it. Okay, A will be walking as a partition to it. Now since A is not there, so it won't be walking as a partition to it. And similarly, the same thing. This C over here, it will be walking as a partition for this A. Okay. If you want me to prove with some sample test case, just write it in the comment. I mean, write it in the live chat that uh, do it with this and prove that the logic works. I'll do it. And if you feel that yeah, you're satisfied with the solution that I've provided, so yeah, you can just write yeah, clear, somewhat like that, so that I can move on. Write something. Otherwise, I'll consider that do for triple A B C B C B C. Okay, triple A B C B C. Add one more B C. Okay, you know the answer, na? Okay. See, first of all, I'll make DPA. Okay, DPA and DPB. Okay. So DPA over here it is 1, then it is 2, it is 3, it is a B, so it is still a 3, it is a C, so it becomes 0. B, 0. I think the stream delay is more than 30 seconds, that's why my response is slow. No, do one thing. Cut off the stream and rewatch it. Okay. Like, I mean, just remove it and open it quickly. It will work. So this C is 0, this C is 0, 0, 0, 0. Okay. DPB is it is going to start from here, 0, 1. Sorry, DP not B, it is DPC. Sorry, my mistake. It is DPC. It is 1, 1 because B doesn't change anything. 2, 2, 3, 3, 4, 4, but there is a A, so it changes everything. 0, 0, 0. So how many B's are there? This is the first B. Whichever is maximum. This 4 or this 3. 4 is maximum, so 4 for this. For this position, whichever is maximum. This 3 or 3. 3 is maximum. Oh, sorry. This is not a B. That and a B. The B is over here. Which is maximum? 3 or 0? 3. So it's a 3. For this, which is maximum? 0 or 2? 2. For this, which is maximum? 1, right? So 4 plus 3 plus 2 plus 1. 4, 5, 7, 8, 9, 10. That is the answer. Okay? And if you want the proof, what is happening basically is very much simple from here. You're not going to consider any of the A's, okay? So for this B, you're first swapping this with this C, this with this with this with this. Okay, so there are total 4 swaps, right? After that, what happens? Now this is a pattern that becomes B, C, B, C, B, C, B, right? Is it so? B, C, B, C, B, C, B. Yeah, right? Now again there are 3 swaps. 1, 2, 3. So there are 3 swaps. So now the same thing. So earlier it was 4, then it was 3, then it will be 2, then it will be 1, and then done. That is what I have done over here. Okay? Is it clear now? Thanks, man. It's clear now. Okay. Great. Okay. So that's it. Let me rate the problems. Quickly, I'll just rate the problems. I'll have just 3 sections for today. Too tired, man. I've been doing a lot of work today. Easy, medium, hard. Uh, so what was the first problem? Subset sum. Easy. Okay, I'll use a different color. Black. Easy. Then the next problem was yet another monster problem. Medium. Okay. Next problem was key boxes. Key boxes I'll rate it as like yeah. Okay, yet another monster was greedy only, but yeah, medium works for it. This will also be medium, just a little bit higher than this. Key boxes, okay. Uh, Swaps in a string, I'll rate it hard, okay. Like if you go to lead code, it will be a hard problem only. Sorry, not key boxes. Swaps in a string. But yeah, it is easy. But in lead code, it's a lead code hard problem. So that's the rating for the today's contest. Okay. So that's it from my side. Thank you. Oh yeah. Anyways, like if you the last question, it is inversion queries. I won't discuss it. It needs to be done using Fenwick tree segment tree. But yeah, I won't discuss it because I couldn't code it down given the time. Okay.